Hi guys, welcome back to my channel Pirai Academy. In this video, we are going to see about more important problem called longest common subsequence Leetcode question number 1143. So before getting into this, I want you to understand the use case and the importance of this longest common subsequence in your real-time examples with your real-time examples. Okay, so this is very much useful in your DNA sequence analysis. Okay, then it is used in your version control like in Git. Okay, in Git you will be merging codes, right? So there it will be useful, and also in your natural language processing it will be useful. Okay, once I just done with this problem, just realize how this problem is going to give the solution for your these three real-time applications if you have time. Okay, so let's get started. This problem is so much interesting also. Okay, now given two strings, text1 and text2, return the length of the longest common subsequence. You don't want to return the longest common subsequence, you want to return the length of the longest common subsequence. If there is no common subsequence, just return 0. Okay, a subsequence of a string is a new string generated from the original string with some characters can be none. Okay, deleted without changing the relative order of the remaining characters. For example, AEC is a subsequence of A, B, C, D, E, because just to remove the B and D, you will be ending up in forming ACE, right? Similarly, a common subsequence of two strings is a subsequence that is common to the both string. So from this you can understand what is meant by common string, right? Now we want to return the possibly the longest common subsequence length. Okay, for example, if it is A, B, C, D, E and ACE, for these both things I can just return ACE is going to be the longest possible common subsequence, because here also ACE, and here also if I delete B and D, then I will be ending up in forming ACE. Similarly here ABC and ABC, so the result will be 3 because ABC is going to be the subsequence, common subsequence, right? Now see here ABC, okay, here DEF, okay, there is no characters which are matching, no characters that are matching, and no subsequence are matching, so I'll be returning 0. Can understand this? Fine. So this is what the problem statement is. Now what is the first approach that comes into our mind? So whenever there is a question like longest, smallest, maximum, minimum, our first thing will be going into greedy, or we are just going into 2 pointers for this problem, because in 2 pointers we already saw a problem like is subsequence or not. So our mind will be directly going to these two approaches. Let us try these two approaches and let us confirm what is the error or what is the characteristic of this problem that didn't lead us to solve this problem in greedy algorithm or 2-pointer algorithm. What is the drawback of using this greedy and 2-pointer algorithm? Okay, just I want you to understand this. That's it. So see here, first of all, I am standing at this A and I am standing at this A. So these two are same. These two are same. So where I will be going? I will be moving this pointer to here. Then I will be moving this pointer to here. Now B and C are not same. Then where should I obviously move? I will be moving this pointer to here. Which means what? I just moved word one's pointer to one step ahead. Okay, so this is going to be a greedy algorithm. Okay, now these two are matching. So two are matching. Okay, two characters are matched. Okay, go here. Now D and E are same. No. So go to E. So E and E are same. So +1 is equal to 3. So 3 is going to be your output. Okay, that's fine. Now we are going to use the same algorithm again also. Okay, let me take the example. So this is going to be your example, right? Now I'm going to use the same algorithm again. How? See here. Now take this as a word one. This as a word one. Okay. Now A and here also A. Whether A and A are same? Yes. So 1 plus. Okay. Now I'll be moving here. Whether B and C are same? No. Whenever it is not same, what I done? I'll be moving one step ahead to the word one. Okay. Now E and B are not same. Okay. One step ahead. That's nothing. So what is my result? It is 1. But I can take ACE, right? So I have two choices. See here, when both are equal, when both characters are equal, then I'll be returning what? Sorry, I'll be making what? I'll be just making my pointers, two pointers +1. Okay, and the result also will be +1. If it is not same, if it is not equal, the two characters are not equal, I have two choice. either make my word 1 pointer plus 1 or word 2 pointer plus 1. Okay, they may lead to any answer. See here, in this scenario, I just made my word 1 pointer to move one step ahead. In this scenario, I want to move my word 2 pointer one step ahead, such that I will be getting ACE. Can you understand where the greedy algorithm fails? Okay, whenever the greedy algorithm and 2 pointer algorithm fails, see here itself you can see we have two possibilities for when it is a not equal case. So from here I can tell you easily, it is going to be combination problem. Whenever it is a combination problem, we want to go for recursion. If you don't know about the recursion, I'll be giving the recursion and backtracking playlist introduction video in the description. Just go and watch that video, then come back, because from that you can understand what is my recursion tree, what is my recursion stack, and how the recursion works, DFS approach, everything. Okay, now let's get started. So now we are just entering into the recursion. Okay, let me take this. So this is our example. Now tell me, what is the first step for for constructing the recursion? So the first step is I want to take a function. Inside that I want to check in the problem what are all those parameters that are varying. So I want a pointer here and a pointer here. That's obviously I want 2 pointers, right? So that's going to be a varying parameter. So let me take as index 1 and index 2. Okay, you may take I, J or S1, S2, that's your risk. Okay, here in this drawing explanation I took as index 1 and index 2. Okay, now how I am going to break this problem into sub problem, because a recursion is what? Recursion is defined as we are having a big problem, we are dividing into sub problem, so that we got a small problem which can be for which we can give a solution directly, so that by using all those solutions we are just going to find a solution for the main problem. So this is what the recursion, right? So how we are going to divide it? Okay, there are two conditions. If both characters are equal, then I'll be just going to index plus 1 and index 2 plus 1. Okay, but also I want to take that particular character as my result, right? So 1 plus. Okay, if it is not, for example, if those two characters are not same, okay, if two characters are not same at index 1 and index 2, then I have two possibility. One of the possibility is, hey, just to go to index 1 plus 1 and remain same on index 2, or else go to index 1 and go to index 2 plus 1. Can you understand this? We have two possibilities here. So this is going to be overall recursion. Till now, if you cannot understand this, I'll be showing you in the recursion tree. Now in that approach you can understand this clearly. Okay, let me take the example again. So this is our example. Now where I should start, I'll be starting from 0, 0. I'm starting from here. Okay, so it is going to be 0, 0. So start from 0, 0. Okay, now whether 0 and 0, so these two indices, these values are same. Yes, they are same. Then where should I go? I'll be going to 1 plus f of 1, 1. Hey, go to first index for the index 1. Okay, and similarly for the first index for the index 2, because 0 plus 1 will be 1. Here also 0 plus 1 will be 1. Okay, and these two characters are matched, so that's going to be my longest common subsequence. These two characters are matched, so A is going to be one of the longest common subsequence, right? So that's the reason I put this 1 plus. Now hope you understand why I put this 1 plus f of 1, 1. Now 1, 1. So B and C, whether these two are same? No. So whenever it is no, we want to try both the things. What are those things? So first of all, I can go to 2, 1. Okay, which means go to the C and remain here as same, or else here move to this E and remain same here. Can you understand this? So if I do that, it will be something like 1, 2, 1, 2. Can you understand what I mean, right? Okay. Now again check whether 2, 1 is same. Yes, it is same. Whenever it is same, what I said, 1 plus f of, go to the next index. Okay, similarly here 1, 2, whether these two are same? No. Whenever it is not same, you have two possibilities. One is 2, 2, another one is f of 1, 3. Okay, fine. Now f of 3, 2. 3, 2 means 3, and here comes 2. So here it is not same. So we have two choices. One is f of 4 comma 2, or else f of 3 comma 3, 3 comma 3. Yes, so these are the two choices I have. So right. No, now here come, it is 2 and 2. So 2 and 2. So whether these two are same? No. Whenever it is not same, okay, we have two choices. One is go to f of 3 comma 2 or go to f of 2 comma 3. Okay, similarly come here 1 comma 3. 1 comma 3 means here comes 1 and 3 is not existed. This index is not existing. So what should I do? I'll be simply returning 0. What this 0 means? Hey, you cannot go further. I have exhausted the one string. So you cannot go further. So I don't have any characters. I will be returning 0. That's it. So this is the meaning of this. Okay. Now again come here. 4 comma 2. What is 4? 4 is E and 2 is E. So these both are same. Whenever it is same, what I told you, it will be 1 plus f of 5 comma 3. Go to one step ahead. Okay. Now 3 comma 3. Whether 3 comma 3 is existed. Here it exists 3, but here there is nothing, right? So I'll be returning what? I'll be returning 0. Okay. Now here comes 3 comma 2. So 3 comma 2. Whether these two are same? No. Whenever it is not same, I have two possibilities. One is f of 4 comma 2. Another one is f of 3 comma 3. Yes. Now similarly 2 comma 3. 2 comma 3 means 2 and 3 is not there. So from here I can tell you it is not existing. So here I'll be returning 0. Okay. Now again come here. So 5 comma 3. Whether we have 5 comma 3? No. Okay. So here instead of this function, so let me take any other color so that it will be more visible. So instead of this entire thing, I'll be just returning as 0. So 0 plus 1 will be 1. So return 1. Can you understand? Now come here. So 4 comma 2. 4 comma 2 means here also E, here also E. So it is valid. Whenever it is a valid thing. So go for 1 plus f of 5 comma 3. Okay. Here it is 3 comma 3. Whether 3 comma 3 exists. Here 3 exists, but here 3 not exists. So what I'll be doing? I'll be just returning 0 here. Okay. Now again come here. So here again for 5 comma 3 we already know there is nothing in this like 5 comma 3. So I'll be instead of this I'll be just returning 0. So 1 plus 0 will be 1. Okay. Again this will be returning 1. Can you understand this? This will be returning 1. Okay. Now see here, this is going to be more important. So for this particular function, what should I return? So in my one recursion call, it is returning 1. In another recursion call, it is returning 0. So the question is what? The question is longest common subsequence. So which is maximum? 1 is maximum. So return 1. Can you understand why I am returning 1? Okay. Similarly here also, I will be returning 1 here. Here it is 0. 0 or 1, which is maximum? 1 is maximum. So instead of this entire thing, I'll be changing as 1. Now 1 plus 1 will be 2. So 2 is returned here. Okay. So here also it will be returning 2. Okay, fine. Here it will be returning 1 because 1 is maximum among them. And here also 1 or 0, which is maximum. 1 is maximum. So here it will be returning 1. So now 2 or 1, which is maximum? 2 is maximum. So instead of this entire function, I will be replacing as 2. Now 1 plus 2 will be 3. And from here it will be returning 3 as my output. Can you understand this? So we don't want the longest common subsequence. We want its length. We found out. Now hope you understand this recursion tree, right? Now tell me what is the time complexity. So I can tell you the time complexity will be over 2 power n cross n, m. Okay, so n is the length of the first string and m is the length of the second string, and space complexity will be over m cross n because of the recursion stack. And this 2 power mn is because of for each recursion, in worst scenario we again go for 2 recursion calls. Then for n cross m recursion, it will be 2 power m cross n. Understand this? So let us see the code, then we can go and optimize it further. So see here, this is going to be the code. So this function is going to be the main function in Leetcode. Now here I will be just returning recursion of 0, 0. So this 0, 0 is going to be your varying parameter. So t1 and t2, these two things are just a static members. They don't change. Okay. Now see here recursion of I and j. So instead of index 1 I have taken as I, instead of index 2 I took as j. You can take anything, S1, S2, your wish, anything. Okay. Now here comes, if my I is reached my T1 dot length, or my J is reached to the T1 dot length, then what should I do? I just return 0, because any one is written in the end, then I should be stopping there and I will be returning 0. Okay. Then if both characters are same, both index characters are same, then I will be just returning 1 plus the recursion call to I plus 1 and j plus 1. Can I understand this? Okay. Now at last, if both characters are not same, then I have two choices. One choice is I can either go to I plus 1 and j remains same, or I can go to I remains same and j plus 1. Okay. And upon these two things, I'll be taking the maximum among them and I'll be returning it. So this is going to be my entire recursion code. Yes, if I submit it, it will be not submitted successfully, because see here, what is the length? It is 1000. It is 1000. But what is our time complexity? It is 2 power n cross m. In worst scenario, it will be 2 power 1000 square, which is exceeding our clock time. What is the clock time? It is 10 power 9. So that's the reason why our recursion code is not submitted successfully. So now it's time to optimize it in regard of space and time. Okay. Now first we can optimize this time. See here how we are going to optimize the time. So now we are going to use a method called memoization. Okay. So the second method. So the first method is going to be your recursion. Your second method of optimization is memoization. Okay. So this memoization can be done in two things. One is using array, another one is using hash map. I want you to do this hash map as by yourself. I'll be teaching this array. By seeing this array, try this hash map by yourself, because hash map is going to be very useful, and also it has much disadvantage than the array. Okay. In array we can further go and optimize, but in hash map we cannot go further and optimize. Fine. Okay. Now why we are going to do a memoization technique. So see here, first of all, here anything is repeating. So see here comes 3, 2. Here comes 3, 2. Here also it is 3, 2. So as you already know, our recursion is a DFS solution, right? So it will be going up to the depth and returning back, up to the depth, then returning back, then go to the up to the depth, then returning back, like that. Okay. So from this I can tell you, this 3, 2 will be encountered first itself, and its value is already computed by using these recursion calls, right? If I store this in my memory, when it is again occurred at this particular point, instead of going to all the recursion, I'll be just returning what's its value, which is stored in the memory, right? So this is the use of the memoization. Okay. So by using this memoization, we don't want to repeat again and again, which process is done already in past. Okay. So how we are going to do the memoization? So the first step is we want to construct the array. Okay. Now how we are going to construct the array? We want to take 3 parameters. One is what is the dimension of the array, whether it is a 1D array or 2D array or 3D array. Okay. And then what's the size of the array? Then what is going to be the initial value of the array? Okay. Fine. Now how many varying parameters are there? There are totally 2 varying parameters. One is I and another one is j. So my 2D array is used here for memoization. Okay. Now what is the size of the array? So see here it is starting from 0, and I will be going up to t1 dot length minus 1, which means n minus 1, because when it is t1 dot length, it is returning 0. So I is obviously going up to what? Up to t1 dot length minus 1. Okay. Can I understand this? So from this I can tell you, we want to construct an array whose row will be of length of t1 minus 1. Okay. T1 minus 1, or t1 length will be going to be t1. So because it is starting from 0 and going up to length of t1 minus 1. Okay. Meanwhile here it will be length of t2. More formally to be understood, I'll be just showing you. Let us take this example. How many what is the length of the first string t1? It is 5. What is the length of the second string? It is 3. Then I'll be having an array of 5 cross 3. So which can be more formally written as 1, 2, 3, 4. Okay. So this is going to be your matrix. So 0, 1, 2, 3, 4, Similarly here 0, 1 and 2. Can you understand this? Can you understand this? Now what is the next step is you want to decide what is going to be the initial value of it. So see here, since it is a length, always the return value will be 0 or positive. 0 or positive, right? It may be 2, it may be 10, it may be 1000, but it will be always not equal to the negative value, right? So here you may fill like -1 or -2, or you may fill null, or you may fill infinity, or you may fill minus infinity. That's your wish. Instead, I will be keeping a symbol as -1. Okay, so -1, -1, -1, -1. So everything is -1. Okay, just think like that. Okay, everything is -1. Fine. Now I want you to understand why we are taking this as -1, right? So I'll be adding 2 lines of code to make this recursion code into memorization code, so that you can understand why we are declaring everything as -1 here. Okay, it is not necessary you want to just take -1. Instead, you can also take -2 or infinity. That's your result. Okay, now at this particular point, after the base condition, you want to add one line like, if, take for example, this array name is dp. Okay, if dp of I and j is not equal to -1, then just to return the value of dp of that particular index. Okay, and then before returning this value, you want to just do one step. So dp of I and j is equal to max of my recursion of I plus 1 comma j comma recursion of I and j plus 1. Okay, then return the result. So what I'm doing in these 2 lines, here I'm just updating it. Here I'm just updating all the values, all the resultant. Here I'm just checking whether it is already computed or not. If it is computed, then I'll be returning from that itself instead of going to the recursion call. Right? So for this reason, for checking reason only, we are just initializing everything as -1. If you initialize everything as null, here also you want to put null. If you initialize everything as -2, here also you want to put -2. But whether you can initialize 0, no, because 0 can be returned anywhere. So you have a slight confusion like, hey, it is already computed or it is returning 0. Can you understand this? Yes. So that's the reason why we are just taking everything as some value which is not in the result of any return values. Now tell me, what's the time complexity? So the time complexity will be O of n cross m, and space complexity will be O of n cross m. So this is going to be your time and space complexity analysis. So now the time complexity is reduced because for each and every recursion call, I don't want to go for that same recursion call. So how many variation will be occurred? N cross m variation will be occurred at the worst time, at the worst possibility, right? Meanwhile, in space complexity also, it is because of 2 things. One is the matrix we have taken. Another one is recursion stack space. Hope you understand up to this. Now let us see the code, then we can go and optimize it further. So see here. So this is going to be your tabulation code. This is going to be your memorization code. First of all, I want to just take the matrix with the dimension and with the particular length I have set in the drawing explanation. Now everything will be same. Here I have used what? Here I have used if it is not equal to null, because my default value here, it will be null only. Instead, if you want to use the -1, then you want to initialize again the -1 to every element of this array. Then you can obviously use here as -1. That's your wish. Okay, fine. Now if it is so, then I'll be returning it. Else you will be going and doing everything similar, but the only difference is, before returning anything, we want to store it. So I forgot here, right, this line. So sorry, before returning we want to update it. So before returning here also we want to update this. So how I am going to update it is dp of I and j is equal to 1 plus that recursion of I plus 1 and j plus 1. Okay, then return the dp of I and j. Can you understand this? I forgot this. Okay, so wherever we return, just update it. Wherever we have a base condition, just check whether it is already computed or not. That's going to be your overall memoization. Okay, I forgot to tell this particular line. Okay, rest of them will be same. So now the program will be submitted successfully because see here it is 1000, right? What is our time complexity? It is n into m. Okay, so 1000 into 1000, which is equal to 10 power 6. So 10 power 6 will be lesser than the 10 power 9, the clock time. So that's the reason why our program will be submitted successfully. So let me take this program, and now we are just getting into the next part, is called tabulation. So for saying the tabulation, I want you to understand why we are getting the space complexity as n cross m, right? So the third method is space optimization, tabulation. Okay, so see here it is because of recursion stack and the matrix. If I eliminate the recursion stack, then one of my space is got eliminated, right? One of my space is got eliminated. So that's the reason why we are just going into a tabulation. So in tabulation, instead of doing the code in a looping, in a recursion, we will be converting into a looping, so that we will be eliminating the recursion stack. So what is meaning of the tabulation is we are just converting the code into a looping format. So here also we want to follow some set of instruction to convert memoization code into a tabulation. If we have done the memoization in hash map, then it is impossible to convert into a tabulation. Okay, if you have done using the array, it is simple. Okay, it is simple to convert into a tabulation. So see here for the example where the t1 length is equal to 5 and t2 length is equal to 3. What is going to be our matrix? Our matrix is going to be 5 cross 3, right? So 5 cross 3, 1 2 3 4, 1 2. Okay, so this is what our matrix. So 0 1 2 3 4, 0 1 and 2. Okay, as I already told you, we can take as null, or we can take as -1, or we can take anything that is not going to be the recursion value. Okay, so here I have took as a null, but in our drawing instance I took as a -1, right? So you can take as a -1, that's your wish. Okay, now the first step we want to do here is check for the base condition. So this is going to be the base condition, right? So in this base condition, what it means if my first index value reaches my t1 dot length, or my second index value reaches the t2 dot length, then what should I do? I will be returning 0. So here in index 1 it referring to 5, in index 2 it is referring to 3. Whether we have 5 as the index for our row? No. So add one more row and name it as 5. So why it is? Because of this particular condition. Because of this particular condition I added here. Similarly here also I want to add one more column. Why? Because they have clearly stated that if my column number is equal to the length means it is 3. So we want another column called 3. So initialize them as 0. Because whenever this values occur, we just return 0 here, right? We just return 0. So initialize here also as 0. Okay. Now what is the next base condition? So next base condition is we don't want this base condition. Just ignore this. Okay. Always. Now remaining everything is a body of the recursion call, right? Body of the recursion function. So whenever we encounter the body of the recursion function, we want to put a loop. So for first thing is I. So I will be from where to where as of this code, will be starting from 0, will be going up to where? Will be going up to t1 dot length -1. If it has gone to t1 dot length, it will be returning 0, right? So it is from 0 to t1 dot length -1, right? So here do a ulta, which means t1 dot length -1 to 0. That in recursion is starting from 0 going up to the length -1. Here it will be starting from length -1 and going up to 0. Okay, similarly for j also take t2 dot length -1 up to 0, because that's what in j also, right? Okay, now get started with the body. So first condition, so write this condition as it is. If my t1 of I is equal to t2 dot j, okay, T2 of j. Okay, then what should I do? I'll be just doing like just take this as memo, okay, or dp whatsoever. Just use this variable here, memo of I and j is equal to 1 plus, here comes what, recursion, which means we are just doing a recursion call. Whenever there's a recursion call, instead of that, again use that memoization matrix. So memo of I plus 1 and j plus 1. That's it. That's it. So these two are the varying parameters. So use them alone. Okay. Okay. Now else part. So here it will be else. So why I am putting else here? Because see here, whenever it is returning here itself, it won't go to the next lines, these lines. So many of them will be making a mistake. They won't put a else here. Okay. Always remember, whenever the program reaches the return part, it will be not executing anything under it. Okay, so that's the reason why we are putting else in this particular part. It is just the programming basics. You want to know about this. Okay, fine. Now else what should I do? Memo of I and j is equal to, so here comes maximum. So write maximum among what? Among recursion function of I plus 1 and j. So instead of that just write memo of I plus 1 and j, comma. Similarly here also, what should I write? Memo of I and j plus 1. So this is what the next recursion call, right? So just write like that. Okay. At last, what should I return? At last. So just return. So what is the return value we are returning here? It is recursion of 0, 0. So here equivalent is memo of 0, 0. Can you understand this? By doing this code, now your time complexity will be O of m into n into m, but space complexity will be O of n into m, but it is only because of matrix, the auxiliary matrix we used. Okay, let us see this code, then we can go and optimize further. So let me comment this. So this is going to be your entire tabulation code. So see here. I have initialized the DP as n plus 1 and m plus 1. I already told you why we are doing this, because we want one more row and one more column to store that 0, the return value, right? So that's the reason why I'm just wrote like this. And you want to just initialize them as zeros. Okay. Now for int I is equal to n minus 1 up to 0, and then similarly for j is from m minus 1 up to 0. And what's the condition? If both are same, I want to go for dp of I and j is equal to 1 plus dp of I plus 1 and j plus 1. Else I'll be taking the dp of I and j to the maximum among dp of I plus 1 and j and dp of I and j plus 1. Can you understand this? Everything are similar to the drawing explanation only. And at last I'll be returning zeros. Can you understand this? Okay. So this is what the entire tabulation code. Now let us get into the space optimization code. So let me take this. So in our previous thing, what is our space complexity? It is n cross m, right? So why it is of n cross m? Because we are taking the auxiliary matrix. Now we are just going to find whether I can edit the auxiliary matrix and make that auxiliary matrix into some quite smaller dimension. Okay, like m or n or even constant. That's up to us, right? So for that we want to follow some set of rules. First of all, check here. dp of I is required. Okay, inner loop. For inner loop, we need all the j values, but dp of I alone required here. dp of I plus 1 alone required here. Here also similarly dp of I alone required. Here also dp of I plus 1 alone required. So apart from that, I don't want any other values. So from here, I can tell you clearly, we only want 2 rows and m plus 1 columns. So which means, for example, next is equal to for 5 cross 3 matrix. Previously we took the 5 cross 3 matrix. Sorry. So first T1 length will be 5. T1 length is going to be 5 and T2 length is 3, right? For that we have taken 6 cross 4 matrix, right? So similarly here I want to take only 4 size. the column plus one size array, 1D array, and then another thing is current, which is also similar to it. Okay, fine. So this is going to be a first step. Okay, now the next step is here. So instead of this line only, we have done these two steps. Okay, now just write these entire line here, okay. The only difference we are going to do is in this line, in this particular line, instead of dp of I, just write like current of j, dp of I and j, right? Current of j is equal to 1 plus, instead of dp of I plus 1 and j plus 1, write like I plus 1 means what? Next. So next of j plus 1. Can you understand this? Okay. Now in else part, write else, and then in else part I'll be writing like current of j is equal to maximum among next of j, comma current of j plus 1. Okay, wherever it is dp of I, write as current. Wherever it is dp of I plus 1, write as next. Okay, at last after this entire for loop finished, okay, after that just initialize your next value inside the current, okay, which means next value as current, okay, which means in next iteration your two values will be going upward, like initially you will be having like this. So here it will be 6, 1 2 3 4 5, right? And then here comes 3. So initially this is how your matrix looks like, right? In previous tabulation, right? Now it is like just come up with the white color. So initially I'll be taking 4 and 5. And computing every values and storing in this fourth in this. Okay. Now for the next iteration I'll be taking 3 and 4, where fourth in this will be my next node, and third in this will be my current node. Okay. Now in next iteration I will be taking this 3 and 2, right? Now in this 3 and 2, here it will be current and here it will be next. Can you understand this? So from this I can tell you we don't want entire matrix. Instead we only want two matrices of size m plus 1. So what is our time complexity? It is m1, but our space complexity will be O of m plus 1. So this is going to be a time and space complexity analysis for the space optimized version. Okay, now let us see the code for this. So it is not a big deal. So see here, so this is going to be your code. First of all, I want the next and the current. Okay, so I have this just initialize them. Now next thing, wherever it is dp of I replaces current, wherever it is dp of I plus 1 replaces next. So do this every time. Okay, at last I forgot to tell you something. Instead of this return value, what should I return? That's going to be the next question, right? Instead of this, you can return like next of 0, or you can return like current of 0, as at last next and current will be same value for the last iteration, right? So you can either do this or do this. So that's the reason why I have written here as next of 0. You can also return like current of 0. So this is going to be your entire solution for your this particular program. Okay, so we have started with the recursion, then we have finally optimized using the space optimization technique. Now hope you understand how far it is like exponential to the polynomial, a quadratic time complexity, right? So this is why this problem is very much useful in your DNA sequence analysis. In DNA, you know, there will be some sequence, right? So in that sequence, it will be more helpful for us to analyze whether it is matching to the another DNA. So longest common subsequence, longest common matching among the two strings in a DNA sequence. Simple. So that's the reason why it is used in a DNA sequence analysis. Okay, now hope you understand what is the application of this problem, how we are just solving this problem using the dynamic programming. And if you really like this video, subscribe to my channel, and don't skip any videos in this DP series, because all videos will be helpful for you to solve all kinds of DP questions. And if you have any doubts, just comment below, or if you found out any mistakes in this, just comment below. And if you want the Python or C++ code, you can get in the description, because I given in the description for the all codes, Java, C++, and Python. Okay, that's it. Thank you.